Alright, I will start things today by thanking you all for coming out to our 2018 Kaskaskia Engineering Banquet. It's a pleasure to see you all here. So, our project this year was to build a pulse jet. And I'm going to try to go over that real quickly here and not take too much of the time up to explain how that works. So, what we have, as in most engines, we have an intake there, an exhaust here, and an area of combustion right there. So what happens? That intake draws in atmospheric air to the combustion chamber. This has to be started by forcing air down there. An air compressor, a leaf blower, those are typically used to start these things and get them running. So once the air has been forced down there, you have atmospheric air being mixed with a fuel source in this combustion chamber. So oxygen, fuel creates an explosion. The fuel source we used was propane. Propane comes in off of a nozzle, which isn't pictured here, through this coil, wraps around the exhaust, comes up the intake, and down into the combustion chamber. So there's no chance for leaks. The nice thing about the way that we've designed this is that if you use a liquid fuel source, as these copper tubes get warmed up from the exhaust exiting out of the back of the pulse jet, you can vaporize a liquid and therefore increase the efficiency of the pulse jet. But moving on to how everything warms up here, you've got an intake stroke which draws in, combustion chamber, which the now rich fuel mixture is ignited by a spark plug, and whenever that explodes, it wants to move somewhere. All that gas expands. Well, you've got a small pipe, and then you've got a larger diameter pipe. The area of lowest pressure or path of least resistance is the larger pipe, so the air moves out in an exhaust stroke. As that moves out, you create an area of low pressure in the combustion chamber again, which is still filling with fuel, because this is a constant flow of fuel, but this air is getting drawn in. And all of a sudden, once that oxygen from the atmospheric air gets in there to a specific point, when the spark plug can ignite it, that propane ignites again, and the process repeats itself over and over and over, thousands and thousands of times. That's pretty much the gist of how these work. But of course, as you have explosions going on in a pulse jet, the exhaust pipe gets hot. That heats the copper, which in turn vaporizes the liquid fuel if you chose to run one. We decided to go, like I said, with propane. Simplest, easiest, less chances for problems as you would run into with gasoline or isopropyl alcohol, or even pure alcohol for that matter. But that's, in short, very, very short and sweet, how a pulse jet engine works. This is a valveless. There are valved. We chose simplicity. We wanted to get this thing done. Wanted to make sure that it ran, and you're going to see that in the upcoming videos. You're also going to notice that there's an air compressor running constantly to supply ours with air. That's more than likely because our pulse jet couldn't achieve the, I'm going to say, RPM, revolutions per minute, technically speaking, to run on its own. It really, really liked a lot of air, and we couldn't supply enough air to get it running on its own. So we used an air compressor to keep it moving. Worked out just fine. It ran. I was actually very impressed with how much air it was pushing out the back. We couldn't calculate thrust. We couldn't quite keep it running long enough. Our coil system, that's what powers this spark plug here. The issue we ran into with it was overheating, and as heat goes up, resistance goes up in an electrical circuit, so it was actually cutting our spark. So, maybe something that a future class can improve on. But it was successful. It ran. And anyway, regardless of all that, I'll cut to the chase here. Regardless, I wanted to thank all of our sponsors for the 2018 year today. I want to thank all of you for coming out, and I do hope you enjoy the following videos of how this thing runs. It was a pleasure to work on.